Hello, in this video I'm going to talk you through how to find a formula for the nth term of a quadratic sequence. It's going to be a multi-stage process, so I'm going to go through each stage one by one, and I'm going to make a little record as I go through of each thing I find on my way to work it out. Okay, so the first thing that I need to do is find what's called the second difference. The second difference is found by first of all working out the differences, which I'm going to do first of all. So from 9 up to 15 is a gap of 6, from 15 to 25 is a gap of 10, from 25 to 39 is a gap of 14, and from 39 to 57 is a gap of 18. The second difference is the difference between those differences. So from 6 to 10 is a gap of 4, from 10 to 14 is a gap of 4, and from 14 to 18 is a gap of 4. If you've done it correctly, you should get the same number for all of those. Okay, so I know I'm correct. So my second difference is 4. Now, the second difference is always double how many n squareds you've got. So once you've got your second difference, what you do is you half it. Every time you half it, and that tells you how many n squareds you've got. So 4 divided by 2 is 2. So I know that my sequence, my formula, has to have a 2n squared in it. So I'm going to write just up here the sequence for 2n squared, which is the square numbers doubled. So 1 squared is 1, doubled gets us 2. 2 squared is 4, doubled gets us 8. 3 squared is 9, doubled gets us 18. 4 squared is 16, doubled gets us 32. 5 squared is 25, doubled is 50. So I've not lined them up very well, but what we then have to do is look at the relationship between 2n squared and the sequence we're aiming for. Now you might notice in this case that every single time if I add 7, I always get to the sequence that I want. So if I want to get to the brown sequence here, I have to do 2n squared plus 7. So that's my formula. And that is the process that you have to follow to find the nth term of a quadratic sequence. So what you do is, number 1, you find the second difference. You half that second difference to get the coefficient of n squared, and then you have to work out as a third step the gap, okay, the relationship between the n squared sequence and what you're aiming for, and that hopefully will then give you the formula. And you can always check that formula is correct by putting in one of the numbers in the sequence and making sure it works. So for example, if I took the 4th number in my sequence, this here is u4, if I substitute 4 in here, I should get out 39. So if I put 4 in here, 4 squared is 16, doubled is 32, add 7 is 39. So I can be quite confident I've got it right. Okay, on to the next one. So my first step is going to be finding the differences. So gap of 3, gap of 5, gap of 7, gap of 9. Now I need to find the second differences. Gap of 2, gap of 2, gap of 2, all positive. Well, that's really good because they're all the same, so that's great. So the second difference is 2. I half the second difference, okay, to get a 1 there. So my sequence is related to 1n squared or n squared. So I'm going to write the sequence n squared, or just the square numbers above. So I'm going to get 1, 4, 9, 16, 25. And I'm then interested in what the relationship is going from this list of square numbers to my sequence. And I can see in this case that each time I have to add 3. Okay, so if I have to add 3 each time, it's going to be 1n squared, add 3. You don't have to write the 1, but you won't lose any marks for writing it because it's not wrong. Okay. Okay, so have a go at finding the formula for the nth term of this quadratic using this rule. Sorry about the paper on top. It's a non-technological solution to me making a mistake. Okay. Oh, no, I'm right in the middle of one. Okay, so have a go at finding the formula for the nth term of this quadratic. Apologies for the paper. It's a non-technological solution to a mistake I made earlier. Okay, so I'm going to go through the process of finding the formula for the nth term of this sequence here. So first of all, you should have found as your differences 15, 25, 35, and then 45. So then our second differences are going to be 10. So second difference of 10, we then half that to get our n squared value of 5n squared. So I need to write the sequence 5n squared above it, or in other words, the square numbers times by 5. So I'm going to get 5, and then 4 times 5 is 20, 9 times 5 is 45, 16 times 5 is 80, and then 25 times 5 is 125. And I'm then looking for the relationship between those two lists of numbers. So 5 down to minus 3, I've got to subtract 8. 20 down to 12, sorry, I've got to subtract 8. And that works for every single one. So my formula is 5n squared minus 8. Okay, let's move on now and have a look at some more complicated ones. Okay, so these ones are going to be more difficult because rather than just adding or subtracting a number every time, we're going to have to add or subtract a linear sequence, an arithmetic sequence. So I'm going to go through the process. It starts off the same. So we look first of all for the second difference. So we've got a gap there of 9, then of 11, then of 13, then of 15. So my second difference every time is 2. That helps me think I'm on the right track because they've got the same number every time. So second difference of 2, that means it's related, if I half it, to 1n squared. So if I write my formula for 1n squared above it, I've got 1, 4, 9, 16, 25. And I now need to look at the relationship between those sequences. So from 1 up to 6, I have to add 5. From 4 up to 15, I have to add 11. From 9 up to 26, I have to add 17. From 16 up to 39, I have to add 23, sorry. And from 25 up to 54, I have to add 29. Okay, so instead of adding the same number every time, I've now got 5, 11, 17, 23, 29. We're going to have to use some maths that you will have done before in order to find the formula for that sequence. 5, 11, 17, 23, 29. Okay, so it's going up in sixes, so it's related to the 6 times table. So it's 6n, and it's the 6 times table moved down 1, so it's 6n minus 1. So it's 1n squared plus 6n minus 1. That's my formula. See if you can have a go at these two here, and I'll talk them through in just a minute for you as well. Okay, so for this sequence here, you should have found that the second difference, I'll just do it for the first 3 just to show you how it works. We're going up in 11, then we're going to go up in 17. Okay, we've got a second difference of 6, and that happens as well here because we're going to get out, we're going to get 23 as our gap for that one as well. Okay, so we've got a second difference of 6. That means it's related to 3n squared. And when you write the formula for 3n squared, the gaps you get are actually giving you the sequence to 2n plus 5. So the formula is 3n squared plus 2n plus 5. Well done if you managed to work that one out, because it's not an easy one to do. The second one, the challenge one, is a really nice sequence that you might have seen before. This sequence here is a really nice pattern you can make with dots. looking like this, and they are the triangle numbers. So if we look at how many dots we have each time, we have 1 dot, then we have 3 dots, then we have 6 dots, then we have 10 dots. And if you actually look at the gaps, we're adding 2, then we're adding 3, then we're adding 4. The second difference is 1. So this sequence is related to half n squared. So this is why it's a bit more complicated. This is why it's the challenge, because it's related to half n squared. If you list the half the square numbers, so that would be half, 2, 4.5, 8, and so on, you'll find that you have to add half, then 1, then 1.5, then 2 in order to reach your sequence. Or in other words, you're adding the sequence half n. So the formula for this sequence is actually half n squared plus half n. It's quite a complicated one, that. Really well done if you managed to work that one out before I went through it.